Championship game, bottom of the ninth, 2 outs, full count. You can feel the tension.
Everyone on their feet. Here comes the pitch.
He fires, fastball, swing,
Crushed.
high,
Still rising.
If you throw a ball, walk across a room, or launch a rocket, the same 3 rules control all of it. These rules were described by Isaac Newton over 300 years ago, and they still form the foundation of engineering and physics today. The reason they matter is simple. Motion is predictable. Objects do not move randomly. They follow laws. If you understand Newton's 3 laws of motion, you understand why things move, why they stop, and how engineers design machines that work safely. In the next few minutes, I'm going to explain each law in plain language, with real examples you see every day. Motion means a change in position over time. If something moves from one place to another, that is motion. If it speeds up, slows down, or changes direction, that is also motion. Motion always involves forces. There is always a cause. For example, when you roll a ball across the floor, your hand provides the force that starts the motion. Friction from the floor provides a force that eventually stops it. Nothing about that is random. Forces explain everything that happened. A force is simply a push or a pull. Gravity pulling objects toward Earth is a force. Your muscles pushing a door open is a force. Friction resisting movement is also a force. Forces are measured in units called newtons. 1 newton is the amount of force needed to accelerate 1 kilogram of mass by 1 meter per second squared. You do not need to memorize that. The important idea is that forces cause changes in motion. No force means no change in motion. Newton's first law says an object at rest stays at rest, and an object in motion stays in motion, unless a force acts on it. This property is called inertia. Objects resist changes in their motion. If a book is sitting on a table, it will not move unless something pushes it. If a puck slides across ice, it keeps moving because there is very little friction to stop it. Your body has inertia too. When a car stops suddenly, your body wants to keep moving forward. Seat belts exist because of inertia. When a car stops quickly, your body keeps moving forward due to inertia. The seatbelt provides the force that stops you safely. Another example is objects sliding off a dashboard when a car brakes. In space, inertia is even more obvious. Astronauts push gently off a surface and keep floating because there is almost no friction to stop them. Motion continues until a force changes it. Newton's second law is the most famous equation in physics. Force equals mass times acceleration. F equals m times a. This law tells us how motion changes. If you apply more force, you get more acceleration. If an object has more mass, it takes more force to accelerate it. That is why pushing a heavy truck is harder than pushing a bicycle. The relationship is predictable and measurable, which is why engineers rely on it. Acceleration does not just mean speeding up. Acceleration means any change in velocity. Velocity includes both speed and direction. So if something slows down, that is acceleration. If it turns, that is acceleration. Even moving in a circle involves acceleration because the direction is constantly changing. For example, a car turning a corner is accelerating even if the speed stays the same. Acceleration does not just mean speeding up. Newton's third law says that for every action, there's an equal and opposite reaction. Forces always come in pairs. When you walk, your foot pushes backward on the ground. The ground pushes forward on you with equal force. That forward force moves you. Rockets work the same way. Exhaust gases push backward, and the rocket moves forward. You cannot have one force without the other. Imagine throwing a ball. Your arm applies force to the ball. That force accelerates the ball based on its mass. That is the second law. Once the ball leaves your hand, inertia keeps it moving. That is the first law. Gravity pulls it downward, changing its motion. When it hits something, forces act again according to the third law. All three laws are working together the entire time. Engineers use Newton's laws every day. Designing cars, airplanes, bridges, robots, tools, and machines all requires understanding forces and motion. Safety systems depend on predicting motion accurately. Efficiency depends on calculating forces correctly. These laws are not abstract ideas. They are practical tools that allow us to build the modern world. If you understand Newton's laws, you understand the foundation of how machines and motion work.